Okay, concept 1 is listing for highest common factors. Okay, so John has a packet of 24 chocolates and a bottle of 18 sweets. He wants to share them with his friends. Each friend must receive an equal number of chocolates and sweets. A is asking for the maximum number of friends he can share the treats with, and B is asking for how many chocolates and sweets did each friend receive altogether. So for this, right, we will have to find out the highest common factor of 24 and 18 first. So we're going to list it out. So we list out for the chocolates first. So we're going to do this listing for factors. So you know the factors of 24 by now. You should know because 24 is a small number. So it's 1 and 24, 2 and 12, 3 and 8, 4 and 6. 6 and 4 is also factor, but you already put it on the list itself. You do not need to repeat it. Okay? And now we have to look for the factors of 18. Okay? Factors of 18 will definitely be 1 and 18, 2 and 9, 3 and 6. That's all. So if you look at these two groups of factors, right, why do we want to find factors? Because the number of friends that John shared the chocolates with must be equal, must be the same as the number of friends he shared the sweets with. So that's why we need to find out, okay? So if you look at this, you know that the highest common factor is actually the 6. And this 6 doesn't mean 6 chocolates and 6 sweets. It means that this will be 6 people. There will be 6 people with 4 chocolates each. Each one will get 4 chocolates. Okay, because this one, if let's say there's only one person, that one person will be taking all 24 chocolates. If there are 2 people, including John, okay, each one will only get 12 because you split the 24 between 2 people. And if there are 3 people, including John, each one will get 8 chocolates. 4 people, each one gets 6 chocolates. 6 people, each one get 4 chocolates. 8 people, each one get 3 chocolates. 12 people, each one get 2. And definitely, if there are 24 people, each one definitely only get 1 chocolate. So when you do this, you can see actually how many chocolates and how many people will there be for each. But then why we do 6? Because the number of friends, the number of people must be equal, must be fixed. So that is why this will be 6 people, 4 chocolates each. This will be 6 people also, 3 sweets each. Because you cannot share like, oh, here, okay, teacher, I know here got 4 people, then here got 3 people. Then this one, here got 4 people, then this here got 4 people, then the extra 1 person don't have any sweets, right? So cannot. We need to find this, okay? So the question number A is asking the maximum number of friends. So if you want to find the number of friends, remember that this 6 people is including John. So you need to take away 1 just to find the number of friends because John is just 1 person himself. So number of friends will be 6 minus 1, 5 friends. Understand? And question B, the number of chocolates and sweets. So if you have this thing here, you're actually able to see how many chocolates and sweets did each friend receive. So over here, each one will get 4 chocolates. Over here, each one will get 3 sweets. So you take 4 plus 3, your answer is 7 treats. Anyone don't understand? Oh, okay, who didn't get it correct? Is the answer 5 friends? Yes, it is 5 friends. Okay? Good. So moving on to question 2. Okay, this one, the numbers are bigger. I know, but you need to do it carefully, huh? So question number 2, it says Peter wants to lay his floor with square carpet tiles. The rectangular shaped floor measures 160 cm by 90 cm. Find the largest possible length of the side of each carpet tile, and B, find the number of tiles that are needed to cover the floor. So what we do is, right, we definitely need to find the highest common factor for 160 and also 90. Because you know that this is regarding square carpet tiles. We need to find the square tiles, okay? Largest possible length of the square tiles. So that means if it's a square, that means that all sides are equal, okay? So the measurement for the square tiles must be the same, understand, for all the sides. So let's find out the factors of 160. So I know it's a big number, so I'm going to list it out, and please check that you didn't miss any factors. So 1 and 160, 2 and 80, 3 cannot, okay? So we go to 4, 4 and 40, 5 and 32, 8 and 20, 10 and 16. Okay, so the next one will be factors of 90. Okay, so definitely 1 and 90, 2 and 45, 3 and 30, 5 and 18, 6 and 15, 9 and 10. Very good. So if you look at these two groups of factors listed, can you tell me which one is your highest common factor? Can you see?
10.
Very good. So you circle 10. But yes, it's 10. But the 10 means what? 10 tiles or 10 cm side? Is it 10 tiles or side of 10 cm? The tiles must be 10 cm by 10 cm. Which one, Nikki? Nikki, which one is it?
9 tiles of 10 cm each.
Very good. So that means the 10, it refers to the measurement. So over here, you have 10 and 16. It means that this one will be 16 tiles of 10 cm each. Whereby this one, that's what Nikki said, 9 tiles of 10 cm each. So the length and the breadth, the side of the square tile must be equal. So that's why the 10 is the measurement. So question asking for the largest possible length. Definitely just 10 cm. Understand, children?
Teacher.
Yeah.
Teacher.
Yes.
Slow down.
I slowed down a bit. Okay. So
Thank you.
Okay, Thierry, I just want to clarify. Do you understand this? Do you?
I'm trying to learn it now.
You're trying to what?
Learn it now.
Learn it now.
Yeah. I don't understand the question.
So, but do you need me to explain again?
No. No.
You can understand this.
Yes.
Okay. So, I'm slowing down a little bit. So this one, you know that the 10 must be the side square tiles, okay? The side of the square tiles, because the measurement must be equal for both the length and the breadth, okay? So you know that that floor is a rectangular shaped floor, all right? So that means you want to find the largest possible length. That means the length of the square tiles must be 10 cm. Okay, so your answer for A is 10 cm. But if we were to do B, I want the number of tiles that are needed to cover the floor. A lot of people will tell me, teacher, 16 plus 9. But if you read your question carefully, the meaning of cover the floor, it means that, right, you are looking at how many tiles is able to cover the area of this rectangular shaped floor. So you're looking at the area in terms of tiles. So you know that the length, you can place 16 tiles. The breadth, you can place 9 tiles, which means that the total number of tiles will not be 16 plus 9. it would actually be 16 times 9. 144 tiles. Because if you find the area, it means it's actually length times breadth. Correct? P3, I believe you guys have already learned how to find area, length times breadth. So if you can,
I P4.
yeah, but I mean P3. When you P3, you learn area and perimeter, remember? So if you want to find area, you should know that the formula for finding area is length times breadth. That's what we are actually applying it here in the question. Okay, so length times breadth. Length can put 16 tiles, breadth can put 9. So 16 times 9. It will be covering the whole rectangular shaped floor with the tiles. So you actually need 144 tiles. Understand, children? Okay. All right. Question 3. John wants to pack 15 red cards, 45 blue cards, and 60 yellow cards equally in boxes without any leftovers. So A is, what is the maximum number of boxes that he needs? B is asking for how many cards of each color will there be. So definitely find highest common factor. So what we are going to do, right? We're going to find out the factors of 15 first. Is for the red cards. So 1 and 15, 3 and 5. That's all. Because there are no more other factors for 15. So we move on to find factors. Yeah, small number, ma. Yeah.
45.
When to find common factor?
45 will be 1 and 45. 3 and 15. 5 and 9. So the rest you cannot already, but then although 9 and 5, but then you already listed there, so there's no need to repeat it. Okay. And then the next one will be the 60 yellow cards. So we look at the factors of 60 also. So it definitely always 1 and the number that is mentioned here, 1 and 60.
2 and 30, 3 and 10.
2 and 30, thank you.
3 and 10.
3 and 20, no 10.
That's 3 and 10.
Yeah, 3 and 10 is 30. So 3 and 20 is 60, okay? And also 4 and 15.
5 and 12.
5 and
12.
okay, any more?
6 and 10.
Yes, 6 and 10. Is there any more?
No.
Very good. Very good. So you have list out the factors of 15, 45, and 60. So you know this one, if there's only one box, all 15 cards will go inside, correct? And over here, if there's also only one box, all 45 blue cards will go inside. Same goes for the yellow. If one box, all 60 go inside. But then if there are 3 boxes, each box will have 5 red. If there are 3 boxes for this, each box will have 15 blue. If there are 3 boxes, each one will have 20 yellow. So 2 cannot, because here don't have 2 boxes. Right? So the number of boxes you know now is actually fixed, which means that the highest common factor is referring to the number of boxes. So the highest common factor over here is 15. Very good, 15. So 15 means what? 15 boxes with 1 red card inside each. This will be also 15 boxes, but each box will have 3 blue cards each. This is also 15 boxes, but this will have only 4 yellow cards each. Understand, children? So now the question is asking me for maximum number of boxes. So you can actually see now I told you that the highest common factor is actually referring to the number of boxes. 15 boxes. Understand? Okay. So once you have 15 boxes, you read question B. How many cards of each color will there be in each box? You do not need to add the colors together because you do not need to add the number of cards. color cards together. You just list them down as what you have listed here. So for the red, how many cards of red in one box? In each box, it will be only one. How many cards of blue in one box? Is actually 3. And how many cards of yellow in one box? Is actually 4 cards. Yes, Chinri, very good. Understand? Okay, so these numbers are actually smaller, okay, like than the one that you do in class. So you just need to understand, must understand what it means, okay? Everyone, any questions? Megan, okay ma? Can huh? Megan, that day you do quite well for this. So yeah, I think you should be able to understand. Don't be careless with the factors. All of you, okay, don't be careless with your factors. If you miss out one, it could be the answer there. So try to be careful, okay? Understand? Okay, can I move on to the next one? Thumbs up, please, children. If can move on, then you CMO. Yeah, I know Kaylin should put CMO one. What's TNCQCU? Can move on to next question. What's CU? I don't know. Okay, I'm moving on. Okay, question number 4. Listing for lowest common multiples. So multiples, I know a lot of students tell me, teacher, multiples are easier than factors. Okay lah. I mean, okay, if you say so. So question number 4. At a ticket booth, every 5th child in the queue receive a popcorn. Every 7th child in the queue receive a cotton candy. Oh, I love cotton candy. What is the position of the second child in the queue who receive both items? So we need to find the first lucky person to get both items. So since every 5th child is going to receive a popcorn, that means we are counting in multiples of 5 for the popcorn receivers. So multiples of 5, let's list out a few. So it's like 5th child.
5, 10, 15, 20, 25, 30.
Okay, thank you. So 5, 5th child, 10th child, 15th, 20th child, 25th, and the 30th, and the 35th child whatsoever, so on and so forth. Okay, you can list out a few. So now we know these are the lucky ones. These are the ones who will receive all the popcorns. But now we are going to do every 7 child receive the cotton candy. So that means the receivers for the cotton candy will be in multiples of 7. So 7 child, 14th person, 21st person,
28.
35th person, yeah, for a second person. So if you look at these 2 rows of multiples, who is that one lucky person who will receive both items? Which one? Position number?
35.
35th. Yes, the
35th
child. So some of you might not be able to understand. Why 35? Because you see that the multiples of 5 are the positions of the children getting the popcorn. These will be the ones getting the cotton candy. So can you see that 35 appears on both? That's the lowest common multiple, which means that the first child to receive both items, the 35th child. Very good. But then I don't want this. I want the second child to
35 times 2 equals 70.
Yes, because I'm looking at the second child means I'm looking at the second common multiple. So I'll have to take 2 times 35. Okay? All right, the answer is 70. Understand now, children? Okay, wait, I haven't clicked 70 here. Okay, anyone do understand? Okay, or thumbs up?
Can move on.
Okay, can move. Okay. I wait for them to thumbs up first. Okay. Wait. Yes, Cherry, correct. Okay, moving on to question number 5. Peter wants to pack some sweets in packets of 3 or packets of 5. What is the minimum number of sweets he should buy? So that means must pack equally into either packets of 3 or either packets of 5. So that means same thing. Lowest common multiple, we are looking at multiples of 3 and also multiples of 5. So let's work multiples of 3 first.
9, 12, 15, 18, 21.
Yeah, so either 3 sweets, 6 sweets, 9, 12, 15, or 18 sweets, and so on. But if you want to pack into packets of 5, it will be multiples of 5. So it will be actually 5, 10, either 10 sweets, 15 sweets, 20 sweets, 25 sweets, 30 sweets, and so on. If you look at these 2 rows of multiples, there is one multiple that is the lowest one. Correct. So the minimum number of sweets is actually 15 sweets, because you can actually pack into packets of 3 without any remainder, and also packets of 5 without any remainder. It fits into the packets. Understand? Yes, Cherry, correct. Cherry, okay, good. Hey, you see, you can do it. You can do very good. Okay. Don't be afraid to make mistakes, y'all. You learn from them, okay? Understand? Okay. Can I move on?
Yes.
Yes, okay, then I will move on. Okay. Yeah. Question number. Question number 6, is it? Okay. Peter had some fruits to give away. 5 of them were rotten and had to be thrown away. The rest could be placed equally into either boxes of 4 or 6. What is the least possible number of fruits that he had at first? Okay, wait, let me check. So that means if 5 of them were rotten and had to be thrown away, the rest could be placed. So that means either boxes of 5 or 6. Remember, it's after you throw away 5, then you are going to put the remaining fruits into either boxes of 4 or 6. So we're looking at multiples of 4 first. So it'll be 4,
8, 12,
16,
20,
20,
24.
24, and so on. But what about boxes of 6? It will be in multiples of 6. Let's say if one box has 6 fruits. So it'll be 6 fruits. There'll be 12, 18, 24,
30, 36.
Yes. So I want to know which one is your lowest
12.
multiple. Yes, 12. Because I want the least number of fruits. This 12 is after Peter threw away the fruits. I want to find out at first.
12 plus 5.
Yes. 12 plus 5. You need to add back the 5 fruits. Although they are rotten, you want to find at first. So you need to add back the number of fruits that you throw away also. So 12 plus 5, answer is 17 fruits. Moving to question number 7. Okay, finding the number of common multiples. So John goes to the library every 2 days. Peter goes to the library every 4 days. How many times will John meet Peter at the library in 20 days? So you know that John is only every 2 days, means he's going in terms of like multiples of 2. But then Peter will be counted his days in multiples of 4. Okay, so let's count John first. Multiples of 2.
4, 6, 2, 4, 6, 8, 10, 12.
Okay, now we look at the days that Peter will go, which is multiples of 4. So 4, 8, 12, 16, 20, and so on. So you know that, you see, if John goes on the 2nd day, he will not bump into Peter, right? Because Peter only goes on the 4th day. So you see that the lowest common multiple for these 2 rows is actually 4. 4 means, right, John and Peter meet at the library once every 4 days. Because can you see every 4 days they'll meet? Understand? So if you look at this now, the question is asking me how many times would John meet Peter at the library?
20 divided
20
by 4.
days. Correct. I need 20 days. So that means in a stretch of 20 days, right? How many times would they meet each other? So since every 4 days they meet, total days.
20 divided by 4.
Yes, 20 divided by 4. Your answer is 5 times. Understand, children? Okay. Answer is 5. Yes. Good. Moving on, okay, to question 8 now. Anyone needs any clarification? No. Okay, I'm moving to question 8 then. Yes, question 8.
Okay.
What?
Okay.
Okay, now the same thing. John and Peter flash their torches at intervals of 6 seconds and 2 seconds, respectively. Okay, so 6 seconds and 2 seconds respectively. Yeah. So how many times would both their torches flash together in 1 minute? Okay, so you know that this John is 6 seconds because the first value, because of the word respectively, the first one go to John, the second one actually referring to Peter. So
just now the question.
you get it wrong.
Yeah.
Okay, so sorry, so that means, so the word respectively, so that means it will torches flash in 1 minute. So John will be counting in intervals of 6, means multiples of 6. Okay, so 6, 12, 18, 24, 30, 36, and so on. You'll flash at the 6th second, the 12th second, the 18th, the 24th, the 30th, and the 36th second. Then for Peter will be multiples of 2.
4, 6, 8, 10, 12.
Yes, on this will be the number of seconds. The second, the second, the fourth, 8, 10. Yeah.
The answer is 5.
What?
The answer is 5.
The answer for this is 10, is it? You are saying?
Yes.
Yes, it's 10.
Yes.
So that means you see this, so if you look at how many times will both their torches flash. So if you look at these 2 rows of multiples, right? The lowest common multiple is 6. On the 6th second, every 6 seconds, both torches will actually flash together. Because John flashed on the 6th second, so did Peter. Okay? So if they give you, let you count, how many times would both their torches flash together in 1 minute? Remember, you're dealing with seconds here. Convert 1 minute into seconds, which is 60 seconds. So if every 6 seconds it flashes, both torches flashes. So in 60 seconds, how many times? You take 60 divided by 6. Your answer is 10 times. Understand? Okay. Can I move on to question number 9? Yes?
Yes.
Good. Okay, I'm moving on to question number 9. Okay, Amber used some strings, colored lights to decorate her room. Okay, so the red light flashed once every 2 seconds. Can you see that? And the green lights will be flashing once every 3 seconds. And the yellow lights flash once every 6 seconds. So how many times will the 3 colored lights flash together in 2 minutes? So let's look at the red lights first. The red lights will be flashing every 2 seconds, means they are flashing in multiples of 2. Yes, Zhao Yu.
Is the answer for question 920?
Yes.
Okay.
So the red one will be every multiples of 2. So you count 2, 4, 6, 8 on the second, the 2 second, the 4th second, the 6th second, the 8th, and the 10th second. The red ones will flash. The green lights is every 3 seconds, so it's the 3rd second, 6, 9, 12, 15, and so on. Okay, but the yellow one will be every 6, so 6, 12, 18, 24, and so on. So if you look at these 3 rows of multiples, the lowest common multiple is actually 6. What does this 6 mean? It means that all 3 lights will flash together once every 6 seconds. Okay, because the 3rd second, none of it flashes. But the 6th second, the red one flash, green one also, and so is the yellow one. So the question asked me to find out how many times would these 3 colors flash together in 2 minutes. So 2 minutes, you need to convert the 2 minutes into seconds. So you know 1 minute is 60 seconds, 2 minutes will be 120 seconds. So how many times will that be? So you just take 120 divided by 6. Your answer is 20 times. Understand, children?